Hi everyone, in this video I want to give you a technique for factoring something we call a perfect square trinomial. Okay, so we have a couple of formulas here. If we have a trinomial of the form a squared plus 2ab plus b squared, we can immediately know by this formula, and I'll demonstrate these are true here in just a second, we can immediately know that we can write this as a plus b squared. And similarly, if we have a squared minus 2ab plus b squared, we can write it as a minus b squared. Okay, so let's work these backwards to confirm that this actually works. So if we have a plus b squared, we can write this as a plus b times a plus b. And now we can just use the FOIL technique. So a times a are firsts. So that'll give us a squared. And we have plus a times b, and plus a times b again, and then plus b squared. And this is just equal to a squared plus 2ab plus b squared. Okay? So this is a formula that will work anytime you see something of this form. And similarly, if we have a minus 2ab plus b squared, we can write it as a minus b squared. To see this, we can go backwards. We have a minus b squared is equal to a minus b times a minus b. And again, we can use the FOIL technique to give us a times a, which is a squared. Then we have a times negative b, so minus ab. Okay, and then we have negative b times a, which is minus a b again. And then we have negative b times negative b, which is going to give us, the negatives will cancel, so we'll get b times b, which is plus b squared. And we can write this as a squared minus 2ab plus b squared. Okay, so anytime you see a trinomial of this form, of either this form or this form, you can write this using this formula. Okay, if you recognize this right away, you're able to use this now that we've proved this. Okay, and you could, if you see this on a test or something, you could always write this. You could always say, because it's a perfect square trinomial, that would be a good enough justification without having to do all of the work. As long as you recognize that it is indeed a perfect square trinomial, you are free to use this formula. Okay, so here we have, in this first example, we have 9v squared plus 24v plus 16. So what we notice right away is that both 9v squared and 16 are things we call perfect squares. And that means we can find some number that if we square it, we get those numbers. So here, we have for 9v squared, we can notice that 3v squared gives us 9v squared. Okay? So if we square 3v, we get 9v squared. And if we square 4, we get 16. So we have 9v squared and 16 are both perfect squares. So this is great. This is really good. Okay, and now the last thing we need to confirm is that this number in the middle is 2 times a times b. Okay? 2 times a times b. Okay, so if we have 2 times 3v times 4. So 2 times 3 times 4. 4 times 3 is 12. Times 2 is 24. And then we just have the 1v, so we get 24v. So this checks out as well. So now, since we have that a is equal to, a is going to be equal to 3v, and b is equal to 4, we can write this as 3v plus 4 squared. Okay, and now let's actually go ahead and check that this does indeed work, so we can check our work on these. Anytime you have something like this, it's not a bad idea to check your work. Okay, if we did this correctly, we should get 9v squared plus 24v plus 16 back. So this is 3v plus 4 times 3v plus 4. So if we do our FOIL technique, we can do our firsts. So 3v times 3v is going to give us 9v squared. 3v times 4 is going to give us 12v. 4 times 3v is going to give us 12v. And 4 times 4 is 16. So we get 9v squared plus 24v plus 16. And that was our original problem. So we know that 3v plus 4 squared is indeed our solution. Okay, so let's look at this one. Here we have 9x squared minus 48x plus 64. So another thing I wanted to say, before you can do this, you do have to make sure it's in one of these two forms. I didn't quite specify that as much on the first one. But so if they're all positive, it's a potential candidate. And if they're all positive except for the middle term here, that is also a potential candidate. But if you say had a negative number for the first part, or a negative number for the last term, these would not probably end up being ideal candidates. It's possible you could factor out a negative number, but that's not often going to be the case. Okay, so occasionally you'll get something where you could factor something out and then use this technique, but for the most part, you're going to see them in one of these two forms, and if you see it that way, then you can use this technique. Okay, so here we do have one in this form. We have a positive number minus a negative number plus a positive number. So let's see if it works. So again, the first thing we have to check is that the first term and the last term are both perfect squares. And we already know that 9x squared is a perfect square because it's similar to the last problem. So we know that 3x, if we square 3x, we get 9x squared. Okay, and if we square 8, we get 64. So both our a and b terms are both perfect squares. That's both our first term and our last term are both perfect squares. So that means that we could say that each of these are our a and b. So we have a is equal to 3x, and we have b is equal to 64. And let's just confirm that this middle term here is negative 2ab. Okay, so negative 2 times a times b will give us negative 2 times 3x times 64. I'm sorry, that's not right. B is not 64. I wrote that down wrong. B is 8. Okay, so that's wrong. B is 8. Okay, so let's confirm this is right. So we have negative 2 times 3x. So negative 2 times 3 is going to give us negative 6 times 8. That's going to give us negative 48, and we just have one x, so we have negative 48x. And that is indeed our middle term here. So we know that we can write this as a minus b squared. So we have 3x minus 8 squared. So let's just confirm that this does work. And you don't have to do this every time, but if you have time on an exam or something, this is not a bad thing to do, is to go back and check your work. It only takes a few seconds, and plus it's good to get the extra practice. So let's go ahead and expand this. So we have 3x minus 8 times 3x minus 8. So if we use our FOIL technique, we have 3x times 3x. That's going to give us 9x squared. Good so far. Okay, 3x times negative 8 is going to give us minus 24x. Negative 8 times 3x is minus 24x. Draw a little line here so we don't run into anything. We can move this over too. Okay. Okay, and then lastly, we have negative 8 times negative 8. That's going to give us plus 64. So we're going to end up here with 9x squared minus 48x plus 64. And that's what we had originally. So we know that 3x minus 8 squared is our factored solution. Okay, but what about if we have something that looks like this? Here we have u squared minus 14u plus 49. Okay, it's worth noting that if we have a 1 out front, 1 is a perfect square because 1 times 1 squared is 1. So it's kind of a strange perfect square, but it is indeed a perfect square. So in this case, we could say that u, or 1u, we could say u squared. If we square u, we get u squared, obviously. And if we square 7, so 7 squared is going to give us 49. So we could say that A is, oh my pen is messing up here. Sorry about this. A is equal to U. Let me plug this in. See if it works. Sometimes you got to reset it by plugging it in. Okay. So here we have A is going to be equal to U. Okay, and B is equal to 7. All right, so we can say, and now we just need to make sure that this middle term here is equal to -2 times A times B. So we have -2 times U times 7. -2 times 7 is going to give us -14, and then we just keep the U, so we get -14U, and that is our middle term here. So we know that we can write this as U minus 7 squared. Okay, and I would encourage you, I'm just for time's sake, I'm not gonna actually just confirm this is the correct answer, but for time's sake, I would encourage you to go back and confirm that this actually works. This is good practice to do. Okay, let's do one more. Here we have x squared plus 18u plus 81. Okay, so this first term we know is a perfect square, because if we square x, we get, surprise, surprise, we get x squared. And if we square 9, we get 81. Okay, so since we square 9, we get 81. That means that A is going to be equal to x, and B is going to be equal to 9. Okay, and since all the terms here are positive, if we make sure that this middle term here is indeed 18u, or sorry, two times, I'm sorry, if I'm going to make sure 18u is 2 times A times B, which is 2 times x times 9, which is indeed 18. Would probably help if I was consistent with my letters here. Let's make this an x. My bad. Okay, so we do get 18x, and we are good to go here. Okay, so my bad. So this should be x squared plus 18x plus 81. So here we have that this should be 18x. So we're good to go here. So that means that we can indeed write this as a plus b squared. So a plus b squared is going to be x plus 9 squared. And again, I would encourage you to go back and double check to make sure that this actually does work.